Hello, my name is Axel Pérez,
And my name is Minauro.
and we're going to present the challenge for Manchester Robotics, which is a PID controller for a DC motor using ROS2.
Well, for the challenge, we were asked to use the ESP32, ROS2, as it was said as previously before stated, and the DC motor.
Firstly, we had to find the PID controller that would help our motor move. After finding its transfer function and by injecting it with a unitary step, we began making tests in the experimental way to find the TKL values using Smith's approximation from 1952. Then, after we got those values, we used Shen, Ropes, and Reswick's method uh, for PID tuning, and after we got a base PID controller, this didn't have the performance we wanted and desired for this controller, so we used empirical tuning to refine the PID controller. We used a sampling time of 15 hertz as it gave us the best value for the times we took samples and how much the information was coming back to the ESP32, and taking into account micro ROS's limitations and other things, we decided to take a sampling time of 15 hertz.
Well, also, after noticing that our PIDs work differently for positive and negative values and also for the nonlinear and linear zones, we decided to implement more PIDs for these different values and these different zones, which well led us for the gain scaling, which we ended up with two. One for the positive values in the positive and negative values in the linear zone, and one with for positive and negative values in the nonlinear zone.
After that, we decided to implement a performance insect node, which would check how our motor was performing using different metrics, such as the total error, the ISEE, the AIE, the ITSE, and ATAE, as well as its peak time, its time, establishing time, overshoot, and other control metrics to see how our control was performing.
And well, in the end, we ended up with a fairly decent model and with really to no error, mistakes, room for mistakes and room for error in our model.
Here's a picture. And for the areas of improvement of our project, we could have had a better tuning of the PID or the gain scheduling with a little bit more time and testing. We didn't have the most stable power supply source as we used a variable tabletop power supply. And
And well, we could very much use a different method for communication. This for a faster response in the Arduino, and will in the motor, and much better and much faster sample times.
that will be all. Thank you.